And today we're going to look at, start to look at graphing these polynomial functions and intervals in terms of where is the graph above the x-axis, right? So I might write where is f of x greater than 0? So that's asking me where is the graph above the x-axis. So f of x representing the y values, right? So where are the y values greater than 0 or positive? And where are the y values or the graph or the function below the x-axis? And we want to be able to do that without a graph by the end of this lesson here, right? So we want to be able to do that without a graph, without a picture, without going to type it into graphing software. Yes, I haven't shared the screen yet. I'm just talking. All right, let me share the screen. So we've got okay. So here we have f of x is greater than 0, where is it above the x-axis? And f of x is less than 0, where is it below the x-axis? Okay, so let's look at a graph. So here we have a graph which we know is a cubic function. It's an odd degree. The ends are going in opposite direction. It's a positive leading coefficient. So what I want to know is where is the graph above the x-axis? Well, if I have a picture, it's pretty easy to tell. I can see where the graph sits on the x-axis by looking at the x-intercepts. So I know it sits on the x-axis at -3, -1, and 2. Where is it above? Well, it's above here, in between -3 and -1. So how do I write that? Well, I write that as an interval. So I say it's all those x values that are bigger than -3, right, to the right of -3, but also to the left of -1 or less than -1. So all those x values between -3 and -1 produce y values that are positive or above the x-axis, okay? And notice that I'm not putting included because we're not talking about the points that are on the line, we're talking about the points that are above or below the line. And it also is above the x-axis here. So I could say when x is bigger than 2 to infinity, okay? Or I could just say when x is bigger than 2, right? So both of those are acceptable. So if I want a left and right boundary, I would say starting at 2 and ending at positive infinity, that's where the graph is above the x-axis. Where is the graph below the x-axis? Well, I can see that also from the grid. So I can see it's below the x-axis here. So when x is less than -3 to infinity, or just less than -3. And then again here between -1 and 2. So starting at -1 and ending at 2. So in between these two numbers, it is below the x-axis. Okay? So let's look at this one. Well, let's look at this one. Well, that's the same one. I guess we'll look at this one. So this is an even degree. Ends up both going in the same direction. So where is the graph above the x-axis or positive? Well, it's above here and here. So here and here is where it's greater than 0. So -3 and 2. So I can say less than -3 to infinity, and also 2 greater than 2 to infinity. Or I could just write when it's less than -3 and greater than 2. Okay, so either interval is acceptable whether you just want to have one value or a left and right boundary. Where is it negative? Well, it's negative in between. So in between -3 and 1, and in between 0 and 2. Now you may see some of these written, especially in the solutions, in sort of a short way. So we could write this interval using brackets. So we might say between -3 and -1. That's a short way to write an interval. So it's not a point. It doesn't mean the point -3, -1. It means between the interval -3 to -1. So not to be confused when you're looking at solutions, that is not a point, it is an interval. So it's just a short way. You'll see that more in calculus, where we tend to use that more often. Round brackets mean not including. So when I use round brackets, I'm saying that it's between -3, but not including -3, up to -1, but not including -1. If I wrote it like this, that means -3 and equal to, right? Square brackets mean including. So if you saw it with square brackets, it means greater than and equal to -3 and less than and equal to -1. Okay, so that's just the difference between the round brackets and the square brackets. So sometimes I use the brackets when I'm doing my interval table, which I'll show you in a minute. It's just a faster, it uses up less space. Okay, so some of them may not be graphed, but this one is in factored form. So it would be easy to graph because I already know the x-intercepts. So I might say, well, where is this function greater than 0? So in order to figure that out, I would need to maybe sketch it. So I know it has roots at x, so 0, x minus 2, so 2, and -1 and -3. So I can put these onto my graph. And I know by the properties that it has a positive leading coefficient. It's opening up. It's going to pass through these x-intercepts. I don't really care where the turning points are because all I am determining is where is it above or below the x-axis. I don't really care where it turns. So in order to answer the question, right, where is it above 0, I have a quick sketch. I know it's above 0 here. So when x is less than -3, I know it's above 0 here, between -1 and 0, and again here when it's greater than 2. So just by knowing those properties of the polynomial, knowing that it's an even degree, the ends will both go up, knowing where the roots are, I can draw a quick sketch and then I can answer the question, where is it above 0? Now, if let's do one more. So what about this one? So this one has roots. So let's say, where is the graph below 0? Well, I know it has roots at -2, 1, and 3, and I know 3 is a double root. Okay, so I know it's got 1 at -2, I know it has 1 at 1, double root at 3, it's an even degree, it's a positive leading coefficient, so both ends should go up, so it's going to pass through this one, go through that one, double root, so turn at that one and go up. So the sketch looks something like that. I don't care where it turns, I just want to know where is it below, and it's below right here, between -2, and +1. Okay? So if I draw a sketch, it's easy to answer the question. What we want to do is to be able to answer the question without drawing it. Okay, so let's go back to this question. We'll do it here. So let's say I wanted to know, well, let's do it this way. We'll do this one. So let's say I wanted to know without graphing. So let's say we want to determine when f of x, let's say, is greater than 0 without graphing. So we are going to use an interval table. And so when you are doing this task or on the strand test, it will ask you to solve this without graphing. Is it helpful for graphing? Yes, it is. The interval table is a good tool to help me graph, especially when we get into Unit 15 and 16, where we're graphing rational expressions, and we don't have graphing technology. So it's easy to help us sketch the graph. So how do we do an interval table? What we do is we put the factors down the side here. So this one's already factored. So I have 4 factors at x, x minus 2, x plus 1, and x plus 3. So this is where my factors go. And then we're going to total it up at the bottom by representing it by the function f of x. So f of x is the whole graph, right? It's all those factors together, gives me the polynomial function f of x. So that's kind of like the total, right? So here are the factors. Across the top, we're going to write the intervals that we want to check. So what do I mean by that? Well, what I mean is that we know where it's sitting on the x-axis. So I know going from left to right, it has an x-intercept at -3, it has 1 at -1, it has 1 at 0, and it has 1 at 2. So if I didn't know what it looked like, I do know where it sits on the x-axis. So what I want to do with my intertable is I want to know what is the graph doing when x is to the left of -3. So what is the graph doing when x is less than -3? So I want to check that interval. The next interval I want to check is I want to know what is the graph doing between -3 and -1. Is it above the x-axis or is it below the x-axis? So I'm going to check the interval between -3 and -1. The next interval I want to check is between -1 and 0. Is it above or is it below? So I'm going to check the interval between -1 and 0. And then I want to check between 0 and 2. And then I want to check what it's doing to the right of 2, so greater than 2. So these are the intervals I want to check. All I'm checking is it above the x-axis or is it below the x-axis? So in order to check, we do a test value. So we're going to pick a number that is anywhere in that interval. So when I check the interval x is less than -3, I want to pick a value that is less than -3 because that value represents all numbers that are less than -3. Okay, it doesn't matter what number I pick. I could pick -4. I could pick -10. I could pick -100. Any number that is less than -3. So I'm going to pick -4. So when x is -4, all I'm looking for is it a positive or negative result. So if x is -3, it's obviously negative. If I put in -3 here, so x minus 2 would become -3 minus 2, which gives me -5. So that's a negative result. -3 or -4 plus 1 is -3. So that's a negative result. -4 plus 3 is -1. So that's a negative result. And then I'm going to total up the signs. So we have a negative times a negative times a negative times a negative gives me a positive result. What does that tell me about the graph? Well, that tells me that f of x is positive which is telling me that the y values are positive, which is telling me that it's above the x-axis. Okay, then I'm going to pick a number between -3 and -1, so I'll pick -2. That falls between -3 and -1. So if it's -2, x is negative. -2 minus 2 is -4, so that's negative. -2 plus 1 is -1, so that's negative. And then -2 plus 3 is +1, so that's positive. So now we have a negative times a negative times a negative times a positive is a negative. That tells me that f of x is a negative value, or y is negative, or it's below the x-axis. Okay, and then I'll pick a number between -1 and 0. So I'll pick -0.5, right? -1/2 is between 0 and -1. So that would be negative, negative. That would make that positive, right? -1/2 plus 1 is +1/2. And that would make that positive. A negative times a negative is a positive. So that tells me it has gone back above the x-axis. Then I'll pick a number between 0 and 2, so I'll pick 1, positive, negative, positive, positive, makes a negative, and then I'll pick a number bigger than 2, I don't know, 10. So positive, 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 positive. So it goes back below and back above. Okay, so if I were just looking at my table and answering the question says, where is f of x greater than 0? Which means where is it above the x-axis? Well, I'm looking for positive results. This is where it's above the x-axis. So my solution will be, it's positive when x is less than 3. -3, I should say. It's positive when x is between -1 and 0, and it's positive when x is greater than 2. And if I look at my graph that I've already done, that confirms it. When it's less than -3, I knew it was positive. When it was in between -1 and 0, and when it was greater than 2. Okay, so I can answer the question. I could solve the problem without drawing the picture. I can just do the table and answer the question. Okay, so let's do a table for this one. Let's erase the graph. Okay, we want to know, if I just was given this, I want to know where is f of x greater than 0. Okay, without graphing it. So I'm going to draw an interval table. And I'm going to look at my x-intercepts are at -2, +1, and 3. Okay, so I want to know the intervals I want to check are to the left of -2. What is it doing? Is it above or below? In between -2 and 1, what is it doing? Is it above or below? In between 1 and 3, and then to the right of 3. Those are the intervals I want to check. So I'm going to write those in my table here. So I want to know, actually I'm going to give myself a little bit more room here, since I have a few intervals. Okay, so I want to know to the left of -3, or -2, my bad, -2, between -2 and 1, between 1 and 3, and then to the right or greater than 3. Those are the intervals I want to check. Okay. Down the side, I'm going to put my factors. Well, I have x plus 2. I have x minus 1. Now you'll see I have x minus 3 twice. So I like to write it twice. You can just square it. So you could put x minus 3 and then square it. Sometimes we forget to square it, so I think it's a good habit to write it twice. Okay, because it is a double root. Okay, so, and then we have f of x at the bottom, the total. So I'm going to pick a number that's less than -2. So I'll pick any number, let's say -3. So -3 plus 2 gives me a negative result. -3 minus 1 is a negative result. -3 minus 3 is a negative result. And then 4 negatives make a positive. Then I'll pick a number between -2 and 1. I'm just going to pick 0 because it's easy. So positive, negative, negative, negative gives me a negative result. I'll pick a number between 1 and 3, let's say 2. So I want to pick the easiest number possible. Obviously, there's infinite numbers between 1 and 3, but 2 is a nice whole number. So I'll pick 2, makes positive, positive, negative, negative, that's positive. And then I'll pick a number greater than 3, let's say 4. Positive, 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 positive. So you'll notice here that we have the same sign. It doesn't always go above and below. Here, remember we had a double root. So it makes sense that the sign stays the same because I am turning at that point and not passing through the x-axis. So that makes sense knowing that that's a double root at 3. So our question was, when is it above 0? I'm just going to write that in. So I'm going to say f of x is greater than 0 when, and I'm looking for a positive result, right? So it is greater than 0 or above the x-axis when x is less than -2. And you can write this as one interval or 2. It doesn't really matter. I could say between -1 and 3 and greater than 3, or we could say when x is less than -2 and greater than 3, right? Because I can kind of combine these two because the sign doesn't change. And if I were sketching, if I wanted help sketching, I know it's positive. I know it's positive less than -2. It goes negative in between -2 and 1. It's positive between 1 and 3, and then it remains positive, and that's because that's a double root. So the interval table also helps me sketch if I had to sketch it. I know it's above the x-axis, it goes below, it goes back above, and then it stays above at the turning point of the double root at 3. So that also helps me sketch if you were asked to sketch it. Right, which is going to be helpful when we get into unit 15 and 16. All right. So let me see if there's any questions. Dylan, yes, if it's a double root, so like I said in the table, you can write it twice, so you can square it. So when you square, it's always going to be positive because you're squaring, right? So it doesn't really matter. It doesn't really matter what it is. Abdel, no, this is not a tech period. This is period 5. So remember the schedule changed today. So period 2 in the morning, and then it goes 3-4 from 12:45 to 1:25. Period 5 from 1:35 to 2:15, and then goes back to period 1. So period 1 is now at the end of the day. So some of you might have forgotten. Anyway, this is recorded, so I will post this video up on the hub, and you can look at it a little bit later. We're going to go over, again, tomorrow will be a work period, but on Thursday we're going to go over how to do the interval table again, and we're also going to do it with factoring. Okay?